Right, let's get straight into it. Welcome to this explainer. Today, we're unpacking a topic that often feels like a completely overwhelming puzzle to a lot of students taking their Cambridge 0580 exams, but trust me, it absolutely doesn't have to be. We're talking about coordinate geometry. Now, instead of just throwing a bunch of disconnected, messy formulas at you and expecting you to memorize them, I want you to look at this as building a visual toolkit. Every single concept we cover today is a specific, razor-sharp tool. And we're going to build this toolkit step by step so you can slice through even the most complex geometric exam questions with absolute precision.
Here is our battle plan for today. First, we'll tackle gradients and how to analyze the slope of a line. Then, we'll move into segments to figure out midpoints and lengths. Third, we'll construct the master line equation. And finally, we'll wrap up the whole shebang by looking at how lines interact when they are parallel and perpendicular. Let's go!
Section 1. Gradients, analyzing the slope. Let's start with the absolute foundation, our very first tool, understanding the steepness and direction of a line. In math, we call this the gradient. Now, before you even touch a calculator or jot down a single number, you can actually learn a massive amount just by looking at the direction a line is traveling. Notice how lines with a positive gradient always slope up to the right. Lines with a negative gradient slope down to the right. Why does this matter? Well, if you can visualize this immediately, you'll instantly know if the math you calculate later on is on the right track. It's your built-in exam defense mechanism against silly mistakes. Before we continue, subscribe to our YouTube channel, Ace the Exams, at AceTheExams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Okay, so what's really interesting is how we translate that visual slope into hard-scored algebra. The gradient is simply the increase in y divided by the increase in x. It's the rise over the run. If you have any two sets of coordinates, let's call them x1, y1, and x2, y2, you just use the formula y2 minus y1 all over x2 minus x1. And here is an absolutely crucial pro tip straight from the source material. It literally does not matter which point you pick to be point 1 and which is point 2. You can swap them around. As long as you are consistent and don't mix up your x's and y's halfway through, your answer will be exactly the same.
Section 2. Segments, midpoints, and lengths. We've got our gradient tool locked in. Now, let's shift our focus. We're moving from infinite lines that go on forever to specific, bounded line segments. We're going to add two brand new structural tools to our kit, the midpoint and the length.
Let's start with the midpoint. Now, finding the exact middle of a line segment might look like a totally terrifying formula with all those tiny subscripts, but I want you to think of it much more simply. You are literally just finding the average. The coordinates of the midpoint are just the mean of your two endpoints. You add your two x values together and divide by 2. Boom, that's your middle x. Then you add your two y values together and divide by 2. Boom, middle y. That's the whole trick. You're just finding the average horizontal position and the average vertical position.
Okay, so we found the middle, but how long is that segment actually? Whenever you have a diagonal line segment on a grid, there is a hidden shape just waiting to help you out. By drawing a horizontal line from your bottom point and a vertical line straight down from your top point, you reveal a right-angled triangle. Suddenly, it's not a weird diagonal line anymore. The horizontal side is just the difference in your x values, and the vertical side is just the difference in your y values.
And here's why that triangle is a game changer. Finding the length of a line segment is literally just Pythagoras' theorem in disguise. Since we've built that right-angled triangle, we know that a squared plus b squared equals c squared. To find our actual length, we just take the square root of the horizontal distance squared plus the vertical distance squared. In formal coordinate terms, it's the square root of x1 minus x2 squared plus y1 minus y2 squared. Sure, it looks super intimidating on paper, but if you remember that visual triangle we just built, the formula makes perfect logical sense.
Section 3. The master line equation. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @AceTheExamsIGC and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's keep building. We have tools for steepness, tools for middles, and tools for lengths. Now we transition to our primary goal for this explainer, taking all these individual, raw pieces and constructing the actual mathematical equation of a straight line.
Meet the absolute master blueprint, y equals mx plus c. Almost everything we do with straight lines in this syllabus revolves around this single, beautiful structure. In this equation, m is the gradient. That's the steepness we calculated back in section 1. And C is the y-intercept. That's the exact, precise point where your line crashes through the vertical y-axis. Now, examiners love to throw equations at you in a messy format, something like ax plus by equals k. But don't panic, you can always use basic algebra to rearrange it right back into our master blueprint of y equals mx plus c. Once it's there, you can easily spot the gradient and intercept.
Let's look at a real example from the text to see how this works in practice. Imagine you are only given two lonely points on a massive graph, 4, 6, and 6, 2. How on earth do we build an entire line equation from just that? Well, first we reach for our gradient tool, y2 minus y1 over x2 minus x1. That gives us a gradient, or our m, of -2. Next, we substitute that m and just one of our coordinate pairs straight into our master blueprint, y equals mx plus c. So we write 6 equals -2 times 4 plus c. Solve that simple algebra out, and you find that c equals 14. Finally, we put it all together. The equation is y equals -2x plus 14.
To make absolutely sure you nail this every single time you sit down for a paper, let's break that mathematical derivation down into a rigid, logical three-step sequence. Step 1, find your gradient, m, using the formula. Step 2, choose just one of your coordinate points and substitute its x and y values along with your shiny new m into y equals mx plus c. Step 3, solve the remaining equation to find c. Once you have m and c, you have the master equation for your line. It's foolproof.
Section 4. Parallel and perpendicular lines. We know how to build a single line, which is great, but coordinate geometry gets really interesting and a bit more challenging when we drop multiple lines onto the exact same graph and see how they interact with each other.
The two major interactions you're going to be tested on are parallel and perpendicular lines, and we need to contrast these sharply in our minds to prevent any exam day mix-ups. Parallel lines are just like train tracks. They run side by side forever and never ever touch. Why? Because they have the exact same gradient. If line A has a gradient of 3, a line parallel to it will also have a gradient of 3. Simple. Perpendicular lines, on the other hand, smash into each other at exactly 90 degrees. Their golden rule is that their two gradients multiply together to equal -1. This means the perpendicular gradient is mathematically represented as -1 over m. We often call this the negative reciprocal. You basically flip the fraction upside down and swap the sign.
Let's move to example 31.8 to see how this concept is built into a real problem. Say we want to find a line that crosses y equals 2x minus 5 at right angles. Well, the original gradient is 2. Because it's a right angle, meaning it's perpendicular, we use our negative reciprocal rule. The new gradient must be -1 over 2, or -1/2. From there, we just do exactly what we did in our three-step sequence. We plug our new gradient and our given coordinate point back into y equals mx plus c to find our new y-intercept.
Now, this leads us to a fantastic boss-level hybrid term you will definitely encounter, the perpendicular bisector. This is a specific line that cuts another line segment exactly in half, and it does so at a perfect 90-degree angle. What's so cool about this is that it forces you to combine multiple tools from your kit at once. To find its equation, you first have to use your midpoint tool to find where exactly in half actually is. Then, you use your perpendicular gradient tool to get that 90-degree slope. Finally, you plug it all into y equals mx plus c. It's the ultimate test of your coordinate geometry skills. Let's pull everything together into one unified picture. If you look at the core principles we've covered today, everything forms a cohesive strategy. We've moved logically from segment formulas all the way to the general line equation, and finally to the rules for parallel and perpendicular lines.
Let's rapidly recap the progressive toolkit we've successfully built. You now have the gradient formula to measure slope. You have the midpoint formula to find the exact center. You can find length by applying Pythagoras. You know exactly how to build the master y equals mx plus c line equation, and you know the rules for interacting lines. Parallel means identical gradients, and perpendicular means inverse, multiplied to -1. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder: subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.
So the very next time you're sitting in an exam hall and you're faced with a complex, terrifying geometry problem, I want you to take a breath. Don't panic. You aren't just staring at a blank graph anymore. You have a complete, powerful toolkit. The only question you actually have to ask yourself is, what specific piece of information am I missing right now, and which of these tools will I reach for first to go out and find it? Think about that as you review these concepts. Thanks for joining me on this explainer, and I'll see you in the next one.